Welcome to Math TV with Professor V. In this video, we're going to learn about solving equations with complex solutions. So first, as a motivation for why we're going to need to introduce complex numbers or even have complex solutions in the first place, I want you to consider the following problem. Say I asked you to solve, let's say I want you to solve the equation 2x plus 10 equals 0. I'm asking you to solve this. And I add the condition that I only want integer solutions. So only integers will be accepted as a solution, okay? Well, could you do it? Sure, you would say, all right, I'd subtract 10 from both sides. So we'd have 2x equals negative 10, divide by 2, x equals negative 5. 5 is an integer, so we're okay. You can make me happy, or whoever's demanding solutions from you. But what if I switched up the equation a little bit, and now I made it 2x plus 13 equals 0, and I still said only integers will be accepted as solutions? Well, you're going to go through the same procedure, subtract 13 this time. So we have 2x equals negative 13, x equals negative 13 over 2, but that's not an integer. It is a rational number, but at this point, whoever's wanting you to solve the equations isn't going to accept that answer. They're saying, I'm only considering integers as solutions. So what would you do? Then you would say, well, I can't find you a solution to this equation because we're being so limited in what we're accepting as solutions. All right. However, if you'll please accept a rational number, then I've got one for you, negative 13 halves. And this is basically what's been going on for your math career up until now. You've been given a limited set of values to work with anytime you're restricted to working with only the real numbers. All right, so if you think about it, now we're gonna get a little more spicy. Say you have an equation like x squared equals 9. And I ask you to solve, I'm not putting any stipulations besides the fact that I want only real solutions, okay? Only real solutions, meaning only solutions that you can find on the real number line, right? So when we say all real numbers, we mean this real number line, 0, 1, negative 1, everything in between. This way is positive infinity, this way is negative infinity. You can find, 1.5, 3 halves here. You can find pi maybe over here, rational, irrational numbers. These are all real numbers. If I give you the equation x squared equals 9, could you find a solution that lives on this number line that's a real number? Yeah, you would go ahead, take the square root of both sides. And then remember, when we use the square root property, we have to add that plus or minus. So we actually get two solutions, x equals plus or minus 3. And sure, no big deal. I can find negative 3 right here and then positive 3 right here. These are my solutions. Yep, I got it. Okay, but then what if we change up the equation a little bit? What if we make the equation instead x squared equals negative 9? Can you find a number on this real number line whose square is negative 9? That when you square it, you get a negative number? No. Okay, that's not possible if you're only looking at the real numbers for solutions. So that's why we introduce complex numbers, because they allow us to solve more equations. And we introduce the imaginary unit I, and sometimes it's referred to also as imaginary numbers. It's a subset of complex numbers. And I hate that word because we associate imaginary with imagination, with make-believe, with pretend, with something that is fantasy that kids do. But these imaginary numbers are not that at all, right? They're very real in the sense that they exist in the world in which we live, and they're used to solve equations that are not make-believe, that are not pretend, but just think they're opening up, they're in another field, okay? So they're outside of the realm of real numbers. I've heard other math instructors refer to them as lateral numbers and the like. So maybe just the terminology of imaginary isn't good, but if you just think of the same motivation that we don't want to restrict ourselves to only real numbers, so we're opening up the field of possibilities for where we can find solutions, then now we're going to have complex numbers, okay? So how do we find a solution to this equation? Well, I'm going to introduce what the imaginary unit I is equal to at long last, okay? So the number I is equal to the square root of -1. That's by definition. And therefore, I squared is equal to -1. So you're wondering maybe, okay, well, how does that help me? This is our imaginary unit. How does this help me solve the equation up above? Okay, well, if x squared is equal to -9, then x is equal to plus or minus the square root of -9. Which I can rewrite as plus or minus the square root of -1 times 9, right? And then I can split up that radical and write it as square root of -1 times square root of 9. Yes, do you agree? And by definition, the square root of -1 is equal to I. So what does that tell us? Well, I can replace it now and say plus or minus, this is equal to I, square root of 9 is 3, so x equals plus or minus 3I. So those are the solutions to the equation. Where exactly is that solution if it's not on the real number line? Well, we can talk about complex numbers, all right? And when we have a complex number, that includes all real numbers and imaginary numbers. So complex numbers have the form a plus bi. It could also be a minus bi. A and b are real numbers. A is referred to as the real part, and b is the imaginary part. If you're going to plot a number in the complex plane, vertical axis is your imaginary axis, okay? And then horizontal axis is the real axis. This shouldn't be a surprise. All real numbers is horizontal anyways, okay? So something like plus or minus 3i, this solution we have here, really it's 0 plus or minus 3i. So the real part is 0. The real part is 0. And the imaginary part is 3. How would you plot it? You would plot it at plus or minus 3 on the imaginary axis. So here's where 3i would be. And then negative 3i would be down here. All right. All your real numbers are here. This real number line is literally the same thing as the real number line we were looking at just a second ago. So now all we've done is introduce an imaginary axis right here, okay? If you say just imaginary numbers, they're here, and the real part is 0. If you say just real numbers, they're here, the imaginary part is 0. This entire plane, these are your complex numbers where they've got a little bit of both. They've got a mix of the real, they've got a mix of the imaginary. So if I were to give you some other complex numbers, say for example, 2 plus 3i, 2's the real part, 3 is the imaginary part. So you would plot it here, 2 is the real part, 3 is the imaginary, it would go right here, 2 plus 3i, etc. Okay? So what we're going to do now is practice simplifying a little bit, and then we'll go ahead and solve some equations once we feel proficient. Okay? So let's just simplify That's usually what the directions say for so many exercises. Say we have for part A, square root of negative 36. Okay, so this breaks down into square root of negative 1 times 36. You can split the radical. Square root of negative 1 becomes I, square root of 36 is 6, and this is 6I. Now you really don't have to go through all these steps every single time, because if you notice, we know the square root of 36, positive 36, would just be 6. So since this is negative underneath the radical, you just slap an I on your answer, okay? See if you can apply that same shortcut for the next one. Say you have square root of negative 75. Well, how would you normally simplify square root of 75? I know 75 is 25 times 3, so it would be 5 rad 3. But since I have that negative, then it's 5I rad 3. And that's it. Okay? Don't put the I at the end ever. You want it in front of the radical, or like I showed you up here too. We don't put plus or minus I times 3. We put plus or minus 3I. All right? Good. I think we're fine. When adding complex numbers, you add the real part, add the imaginary part. So say you had 4 plus 5I plus 3 plus 9I. You would add the real parts together. It's just like combining like terms. So this would be 7 plus 5I plus 9I is 14I. All right. Pretty easy, I think. Things can get a little more complicated when we're multiplying, so you would still, FOIL and do all that good stuff, but just remember that I squared is equal to negative 1. Okay, keep that in your mind. So let's try this example here. 6 times 3, that's 18, plus 24I from right here. Then this is minus 15I minus 20I squared. And then we can clean up. So let's see. This is 18. 24I minus 15I, that's going to give me 9I, positive 9I. And then remember, I squared is equal to negative 1. So really over here I have negative 20 times negative 1, which means that's a positive 20. And positive 20 I can add with 18, so that's 38 plus 9I. And you do want to write your answer in that standard form A plus BI, where the real part comes first and the imaginary part comes second. Okay? Good. There's some other things that you can do with complex numbers, simplifying higher powers and dividing them. I'll cover that in another video, but I just want to get the basics out of the way so we can start solving equations, okay, with complex solutions. So let's look at one example where we're actually solving an equation. That have complex solutions. And let's start off with some quadratic equations. So solve over the complex numbers, okay? We're okay with imaginary solutions. So first example, x squared plus 3x equals negative 7. All right, with any equation that's quadratic or higher, when you have a squared term and then a linear term, etc., best bet is just set it equal to 0. Okay, so x squared plus 3x plus 7 equals 0. Does this factor? No, it does not. I am so very sorry. Okay, so what we're going to have to do is bust out the quadratic formula. So x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, good. And then let's keep simplifying. So x equals negative 3 plus or minus square root. This is going to be 9 minus 28. Yes, over 2. Very good. Okay, 9 minus 28, that's going to give me negative 19. So x equals negative 3 plus or minus the square root of negative 19 over 2. Do you remember how we will simplify the square root of negative 19? 19 doesn't simplify, right, as a radical. So in your head, maybe you're thinking it's negative 1 times 19. Split up the radical. Then you have I times rad 19. Like I said, you don't have to show all that work every single time. You can just slap an I on it, basically. Get rid of the negative and put an I in front of the radical over 2. And that's it. Okay? How was that one? Not too awful, right? Okay. Let's look at some more. Something a little trickier, perhaps. Higher order, dare I say. We're going to give it a go. Okay. All right, moving on. Let's look at another example. Here we have x to the 4th plus 5x squared plus 4 equals 0. Fortunately for us, this equation actually factors. Can you notice? We have x squared plus 1 times x squared plus 4 equals 0. So it factors just like a normal quadratic trinomial would, but we have x squared and x squared instead because these were both, this is x to the 4th. All right. Now again, we're going to apply the zero product property. So I'm going to set each factor equal to 0. And then from there, I can use the square root property, a little bit easier to solve. So this means x squared is equal to negative 1. When I take the square root of both sides, remember we have to put a plus or minus in front of that square root sign. So I get x equals plus or minus the square root of negative 1 is I. Or we have x squared equals negative 4. And then same thing, take the square root of both sides, plus or minus. And then we have x equals plus or minus square root of negative 4. Just think to yourself, whatever the square root of 4 is, that's 2. Since there's a minus sign underneath the radical, you're just going to slap an I on there. So plus or minus 2i. Okay, very good. And we can tell now we actually have a total of 4 solutions, plus or minus I and plus or minus 2i. Really, the most proper way is to put them in a solution set. Okay, and it's no surprise to us that we have 4 solutions because notice this original equation was a degree 4 polynomial, and later if you study the fundamental theorem of algebra and the nature of solutions, whatever the degree of a polynomial is, that's how many solutions it will have, as long as you allow complex numbers to be part of your solution set. Okay, if you say only real numbers, then you're not going to find all of them. All right, let's do a few more. On that note, let's get a little exciting and spicy here. Say I'm asking you to solve x cubed minus 1 equals 0, and I want all solutions, okay? We're giving real and complex solutions, so here's the thing. X cubed is degree 3, so I'm really on the hunt for 3 solutions. And I'll show you how you would go wrong. If you just said, oh, I'm going to move the 1 over and then take the cube root of both sides, okay, that's fine and dandy, but then you would only end up with x equals 1. And I told you, since it's degree 3, there's going to be 3 solutions. So where are the other 2? What you need to do instead, don't do this. Don't do this. What you need to do instead is factor. Do you remember how to factor a difference of cubes? If not, I have a video. I'll link it here. You can watch, but I'll just review the process. It factors into a binomial and a trinomial. And since this is subtraction, I just think of SOAP. So you have the same sign, meaning subtraction again. Then you have the opposite sign, and the last one's always positive. So same, opposite, and then always positive. Soap, okay? And then x cubed means this is going to be an x. Cube root of 1 is still 1, and then the pattern is x squared, a squared, and then it has ab. 1 times x is just x, and then 1 squared is 1. All right, so now that we have x cubed minus 1 factored, we're going to use the zero product property. So we have x minus 1 equals 0, or x squared plus x plus 1 equals 0. And we can see here, all right, x minus 1 equals 0. That gives me x equals 1 as a solution, which we were able to find when we just moved the 1 over and took the cube root. But the other two solutions that we were missing are sitting right here in this quadratic equation. How are we going to squeeze them out of there? Well, we're going to have to use the quadratic formula because this is not going to factor. So x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. So x is equal to, let's see, negative 1 plus or minus square root 1 minus 4. That's going to give me a 3 underneath, oh, negative 3, excuse me, underneath the radical over 2. And then simplifying that, square root of negative 3 is just I rad 3. So this is negative 1 plus or minus I rad 3 over 2. All right, so that's two solutions, right, because of the plus and minus, and then I also have positive 1. So let's put all three together in a little solution set. All right, so I'm just going to stop there. We could do so many examples, but I already have video lectures in more depth, you know, on pre-calc and in my other classes, solving equations that involve complex solutions. But hopefully that was enough of a refresher if you just needed to kind of brush up on things. And then I'll go back and make some more intermediate algebra videos where we break through solving equations and kind of go through the basics a little bit more. But hopefully this was helpful. If it was, please give the video a thumbs up. Subscribe if you haven't already. And stay tuned. Always let me know what sort of content you need. I'm happy to take requests. This one was a video request. So keep working hard, guys.